If you have answers, you can put your answers in the chat. Otherwise, I'm just going to fill it in. This is just the warm-up. For the first unit equation, you need to fill in the prefix. So you find 0.1 on the chart. There's 0.1, and that's deci. So you put a D there. That's how you would complete that one. For the second one, we've got 1 centisecond. So you look up centi, which is right underneath. That's what the C is. And that's 0.01, which is the same as 1 times 10 to the minus 2. So you can put either one. So that's a refresher for how to use the chart. Any questions there? If not, you can let me know that you're good. Alright, then let's move on. This is kind of due now part 2, but it's the conversions review. So you're waiting in line at Chick-fil-A. There's 8 people in front of you. If the total distance between you and that pleasant employee ready to take your order is 54 feet, how many centimeters are between you and delicious destiny? I already gave you the first unit equation, and that will help you go from the number of feet to the number of meters. You need to figure out the second unit equation, which relates centimeters and meters, and then figure out the rest of the problem. So I'll give you another 3 minutes to get started, and then I'll start filling in some things, and we'll solve it together. Let's get started with this one. If you have an answer, you can put it in the chat. Otherwise, you can just watch and wait for the reveal. With this question, we have 54 feet, and we're trying to convert that to centimeters. So the first conversion we're doing is English metric, and I gave you that unit equation. 1 meter is equal to 3.28 feet. We can write unit factors for that, which are just the fractions. Put 1 meter in the top, 3.28 feet in the bottom, and then you flip it over. That's the first unit equation. The second unit equation, you have to relate centimeters and meters. What is my unit equation for that? You can write it in the chat. Yeah, so you gave me so that is one way to write it. Or you can write 1 centimeter is equal to 1 times 10 to the minus 2 meters. Either way is right. Yes. The -2 tells you how many decimal places. So the 2 tells you 2 decimal places. The negative tells you that it's a number smaller than 1. So if I were to write this in regular number format, I'd start with the 1, and there's kind of an implied decimal point here. I would move the decimal point 2 places to the left, 1, 2, and place it here. So my actual number would be 0.01 meters. It's the same thing. Does that help? You're welcome. So as usual, baby Hefner has made an appearance and he needs mama. So give me 1 minute to get him squared away and then we'll get back to the problem. Alright y'all, sorry about that. So here we go. We're going to go with, we're only going to use one of these unit equations over here. We'll use the top one since I got that one first. We can write our unit factors. If you use the other unit equation, that's perfectly fine. Your equation will look a little bit different, but you should get the same answer. Starting with 54 feet, we're trying to go from feet to meters and meters to centimeters. Which one am I using to get from feet to meters, A or B? So we're going to use A, and that's because the feet need to be in the bottom, the denominator, so we can cancel out the feet in the top. For the next part, we're going from meters to centimeters. Are we going to use A or B? Remember, we have to cancel out meters, which is already in the numerator. We're going to use B. And then, as usual, we need to double check and make sure that our units cancel. So the first part of this, we're supposed to end up with meters, and we do. Then, we're supposed to cancel out meters and end up with centimeters, and we do. If you didn't get an answer, you can go ahead and try to put this into your calculator. I'll write in purple how you put it into your calculator. 54 divided by 3.28, and then you multiply that by 100. So that's what I got from my calculator answer to 1646.34. But we have to worry about sig figs. 54.0 feet. How many sig figs does that have? It's got 3. So what's our answer to 3 sig figs? Remember, we need that placeholder 0. If I gave you $165 instead of $1,650, you'd notice a difference. So you have to add that 0. It's still 3 because that 0 is a placeholder. So you put the 0, you don't include a decimal point at the end. The other way that you could represent that would be 1.65 times 10 to the third centimeters. So simply use scientific notation, and then you don't even have to worry about placeholder zeros. Either answer would be fine. Other questions? Let me know how we're doing with this one. Okay. So that's all we're going to do for review of last week. We will have exam 1 review next week, and we'll make sure to do some more of those conversion problems. I will post an exam review, and I'll talk about this again at the end for people who missed it. I'll post an exam 1 review along with the answer key. So that will have practice. I'll also post a chapter 2 practice problem set. So there will be plenty of ways for you to get practice and get help. Today, what we're doing is we're finishing up chapter 2. We got to talk about volume. We have to talk about density, temperature, and specific heat. Hopefully you got a chance to watch the video. I'm not going to go into a whole lot of detail for some of the more nitty-gritty things or kind of fun facts. We're just going to get to it and do some problem solving. So for the rest of the session, it'll be like me doing a practice problem, getting some input from you, and then you're going to have a problem of your own to try, and then we'll come back together. So here we go. Volume. I'm sure that you have heard of volume since you're in college. Length times width times height. You might also see length times width times thickness with a T. Same thing. That's how you calculate volume. And the units for volume would be some kind of distance measurement like centimeters cubed or meters cubed. But it's going to be cubed because you're multiplying 3 lengths or 3 measurements of distance. So you get cubed. But let's say you have a volume and you want to convert that volume into a different unit. Then how do you do that? That's what this problem is talking about. We've got the volume of a Rubik's Cube, which I don't know if anybody even knows what that is anymore, but this is a Rubik's Cube. It's really big in the 80s. What's the volume of this Rubik's Cube in meters cubed? We've got it in centimeters cubed. We want it in meters cubed. When we say centimeters cubed, that's like saying centimeters times centimeters times centimeters. And we want to change that to something that's meters times meters times meters. So whatever unit factor we use to convert from centimeters to meters, we actually have to multiply by it 3 times. And I'll show you what that looks like. Now we just used this unit equation for centimeters to meters. This time we'll do 1 centimeter is equal to 1 times 10 to the minus 2 meters. Write out the unit factors like we've been doing. And if I'm going too fast through this part, let me know. This is literally the one that we just did with the Chick-fil-A question. So that's why I'm just kind of jotting it all down. But if that's too fast, if you're like, wait a minute, let me know. Speak now or forever hold your peace. Sure. So that's really the only part I was going to write through real quick. And that's the unit equation that we used. Okay. So we said we would use B. We've got centimeters down in the bottom. I'll use some different colors here too. So that gets rid of centimeters a second time. And then we have to do that one more time. And now, when we go through and do the math, you're doing 185.2 times 1 times 10 to the minus 2, and you're doing that 3 times, so that's cubed. Put that into your calculator and let me know what you get. Good. You should get that. Let me get back to my black here. So your calculator probably did something like this. And you can rewrite this in scientific notation, which would be 1.852 times 10 to the minus 4. And that's meters cubed. But the crux of this whole thing is understanding this part. To convert centimeters cubed to meters cubed. Let me know how we feel about this. I have a practice for you to do. So if you just want to try the practice, let me know that. If you need to go through this again, let me know that. Yeah, I have another one already queued up. So if we're good and we want to practice, then let's do it. Okay. Still with the same Rubik's Cube, but this time go from centimeters cubed to inches cubed. Now that you're not going to get on the table that's in the chapter 2 lecture. Whenever it's a metric to English or English to metric, I will provide the unit equation. So 1 inch is the same as 2.54 centimeters. That's your unit equation. Figure out the unit factors and which one you need to complete the conversion. I'll give you 3 minutes to start working on it. You could put your answer in the chat when you get it, or you could hold on to your answer and wait for me to go through it. Whichever one you want to do is fine. 3 minutes. I'll check back. Okay, go ahead. Yeah. No. So this unit equation tells you all you need to know. 1 inch is the same as 2.54 centimeters. And you're just trying to get from centimeters cubed to inches cubed. I'll start writing out the problem, and then I think it'll become clear. So the unit equation was given. 1 inch is equal to 2.54 centimeters. We write unit factors from there. 1 inch over 2.54 centimeters and 2.54 centimeters over 1 inch. If I'm trying to go from centimeters to inches, which one of these unit factors would I use, A or B? Yeah, we'd use A. But remember that we have to use that same unit factor 3 times. I hope no one is red-green colorblind. If you are, you can let me know. You can send it in a private chat if you're not comfortable. Just that I know not to use the red and the green in the same problem. Oops. So when you do all that math and you put it into your calculator, what you're really doing is 185.2 times 1 over 2.54 cubed. Your calculator is going to tell you 11.3015 and a bunch of other numbers. That's the calculator answer. We've only got 4 sig figs in our volume, so we can only have 4 in our answer. That 0 would be the 4th significant figure. We look at the 1 to see if we round up or stay the same. Since it is definitely less than 5, we're going to just drop everything after that 0 and include our units. So I know someone was asking about Do we have to convert and somehow bring in meters into all of this? The answer is no, because we don't care about meters in this question. We care about centimeters to inches. Okay, there's a question, how do we have 4 sig figs? The only number in here that we care about is the volume. This unit equation, don't worry about it. The unit equation, we're not looking at that for sig figs. We're only looking at the volume. And it's got 4 non-zero digits, so that means that each one of them is significant. So there's 4 sig figs. Does that answer your question? Good. Yeah, this one is considered exact, an exact number, the 2.54 centimeters. In an exam setting, I would never set you up like that. I wouldn't trick you. I'd let you know. So that's how we convert volume. Questions on that? Let me know if you have questions or if you're ready to move on to the next topic. Good. So we're still going to be talking about volume, but we're transitioning from volume to density. We won't always be able to do the simple calculation of length times width times height to figure out what the volume of a solid is. It may be a little bit irregular. In that case, we'd use something called volume by displacement. And this time we're talking about solids. If you have a graduated cylinder with a certain amount of water in it, say 30 milliliters, and that's our initial volume, then you put a sample into that graduated cylinder. The level of the water is going to increase. Whatever that volume is your final volume. I gave the example of if you take a regular bath in a bathtub, like fill up the tub, when you sit down into the water, the level rises. It's the same exact idea here. And the difference between when you first filled the tub and when you sit in the tub, that's the volume. So the volume of our solid is equal to the final volume of the water minus the initial volume. In this case, we've got 38.0 milliliters minus 30 milliliters, and that gives us 8.0 milliliters. Now, it's customary to report volume for solids in centimeters cubed. 1 milliliter is equal to 1 centimeter cubed. I talked about that in the video. You don't have to know how or why, but know that this is true. So we can write that 8 milliliters as 8.0 centimeters cubed. So for volume and solids, we use centimeters cubed. For liquids and for gases, we use milliliters or liters. So that's a little tidbit that I went over in the video. Not going to go into detail on that. You don't need to know why or anything like that. Just take my word for it. The major point on this slide is understanding volume by displacement. You put the sample into water, you see the difference in volume, and that difference in volume is the volume of your solid. Let me know if that makes sense to you and you're ready to move on. If not, ask your questions. Yeah. Yep. So what we're doing is we're kind of laying the foundation. We're going to get to using this volume by displacement when we're talking about density. So we're not going to do a sample problem yet. I want to talk about volume by displacement with gases first, and then we'll start talking about density. Is everybody good with that? I see a couple of y'all were saying ready to move on anyway. So we'll move on to talk about volume by displacement for gases. And we're not going to talk about gas density here. We're not going to do any sample problems like that. But you do need to know how you need to figure this out. If you have a reaction going on in your tube and it produces gas, that gas is going to go through this tube and press down on the water that's already in this flask. It's going to exert pressure on it. That's going to cause the water to go up the tube and exit into this beaker here. The displaced water, the volume of the displaced water in this beaker is equal to the volume of gas that you have. So if there's 100 milliliters in this beaker here that I circled, then that's the same volume as your gas. Does that make sense? Sure. The whole thing or just the last part about the 100 milliliters? Okay. So if you have 100 milliliters in this beaker here that I circled, that means the gas displaced 100 milliliters and your volume of gas is also 100 milliliters. It's just an example. It can be whatever you want it to be. But if there was 95 milliliters, if there was 10 liters, then whatever number that is for the water, it's the same for the gas. I know there are several of you who's saying like, yeah, I get it, and that's cool. I want to make sure the people who don't get it, that y'all are okay. So is it starting to sink in a little bit more now? Good. So we covered volume. We talked about how to convert volume, centimeters cubed to meters cubed or something like that. And we know how to calculate volume, length times width times height. We did that in geometry class in high school, maybe even middle school. Now we're going to talk about density. Density, it's just a measure of how much stuff you can fit in a space. So if you think about a dorm room, if you live on campus, versus maybe your room back home, trying to take all the stuff from your room back home, which is probably bigger, hopefully bigger than the amount of space you have in a dorm room, especially if you share a room. You're trying to cram all the stuff in a big space into a smaller space. Density, the amount of stuff, the amount of clutter in your dorm room, probably a little bit higher than a room where you can kind of spread out. It's a similar idea when we're talking about density. A substance that is very dense, you can fit a lot of matter in a small space. The way we calculate density is you take the mass in grams and divide it by the volume. The density of a solid, you'll see that represented in grams per centimeter cubed. For a liquid, it's gram per milliliter. We're not going to talk about gases. We're not going to do any gas examples. I'm not going to put that on the exam. We have a whole chapter dedicated to gases towards the end of the semester. That's when we'll talk about gas density. So we'll only focus on liquids and solids. These are the units. Let's do a very quick sample problem. A metal solid has a mass of 51.2 grams and a volume of 6.50 centimeters cubed. What is the density of the metal? This is a very simple density question where all you have to do is plug in the numbers into your calculator. Go ahead and do that now. We know the mass is 51.2 grams and the volume is 6.50 centimeters cubed. Put that into your calculator and let me know what you get. Yes, we do. You can tell me what your calculator answer is, or you can tell me with sig figs, whichever one. I'm not picky right now. Great. Thank you. So that's our calculator answer. But as somebody put in the chat, we need 3 sig figs because our volume has 3 and our mass has 3. So with 3 sig figs, yeah, go ahead. If the volume, say, had 5 sig figs and the mass only had 3, we would still only use 3 sig figs. With multiplication and division, you use the number of sig figs that's equal to the number of sig figs in the measurement that has the fewest sig figs. 3 sig figs will always be less than 5. So we do 3 sig figs. Mm-hmm. Yes. but that's only with multiplication and division. That 7 is our third sig fig, so that's the one we're going to round. We look at the 6 to see if we round up or stay the same. 6 is definitely 5 or greater, so our actual answer is 7.88, and we need to include our units. For solids, for density, we use grams per centimeter cubed. So I saw a few people had put it in the chat already. Thank you. Great job. Whenever you want to work ahead of me for a problem, you're more than welcome to. Everybody kind of learns at their own pace. I try to go at the slowest pace possible to still keep us on track time-wise. If that pace is too slow for you, you can work ahead and then wait for the answer. That's perfectly fine. So this is the most straightforward density problem that you'll get. Here's a mass, here's a volume, figure out the density. Chances are it's not going to be that simple. So let's take it up a notch. Aluminum has a density of 2.70 grams per centimeter cubed. What is the volume of a piece of aluminum with a mass of 28.3 grams? If you want to work ahead and solve it, go for it. Otherwise, I'm going to walk through this one, and then you can do your... I have another problem that's similar to this that you'll try on your own. This is still a density question, but this time we need to know the volume. We're dealing with a solid. Aluminum is a metal, it's solid. So that means that our units are going to be centimeters cubed. How many sig figs should we include in our answer? 3 sig figs. Right. Because each of the values that we have has 3 sig figs. What we're given is a density, and we're also given a mass. That's directly from the problem. But we also know something. Density is equal to mass divided by volume. You can solve this equation for the volume. What I'm going to do first, which is the easier way to think about it, is multiply both sides by volume. That gets the volume out of the denominator and a little bit easier to work with. Now I'm going to divide by density on both sides. We've got volume on one side, and we've got mass and density on the other. Now that we've got this equation, we can fill in the information that we know. The mass was 28.3 grams. The density was 2.70 centimeters, grams per centimeter cubed. Let me know what you get. What is our volume here? So the units are centimeters cubed because we're talking about a volume. And that's what I did right up top to say, okay, the question is a volume, so that means my units should be centimeters cubed because we're talking about a solid. Now, the other way that we can write this is to use density as a unit factor. So I'm going to rewrite our equation just slightly differently. That's density as a unit factor. That's exactly what it is. It's 2.70 grams for every 1 centimeter cubed. That's what density means. And that's exactly what we did with our math. We just didn't write it this way. So it's the same thing. And you can see how the units work out. Whichever way makes sense to you, whether it's writing the density as a unit factor or doing the algebra to rearrange the equation, whichever one makes sense to you is the way that you use. So talk to me. How do we feel about this problem? Yeah, that's fine. I've been doing this for a long time. I write fast, and I know what I'm writing. It's harder you write slower when you're writing down the notes than when I'm writing it down. It's all in my brain. So if you need me to slow down, that's totally fine. You can always let me know. Correct. Okay. Now I want y'all to try one on your own. You've got liquid mercury with a density of 13.6 grams per milliliter. Now, mercury is a metal, but it's a weird metal, and at room temperature, it's a liquid. What is the mass of a 61.0 milliliter sample? To help you get set up a little bit here, we're looking for a mass. So that means our answer is going to be in grams. How many sig figs should our answer have? It should have 3. Because that's all we have in the problem. You know that density is equal to mass divided by volume. And from there, you should be able to solve this problem. So I will give you 3 minutes. Work on it. You can put your answer in the chat, and then I'll get to solving it. If you have any questions, you could put them in the chat or just ask. I'm just sitting right here. How are we doing? Are we ready for me to solve it, or do you need a little more time? Okay. Then I'll get started. We know that density is equal to mass divided by volume. If we want the mass, then all you got to do is multiply by volume. Now let's go to our question. We've got a volume of 61.0 milliliters. And our density is 13.6 grams for every 1 milliliter. The milliliters cancel. We have grams. This is our calculator answer, 829.6. We only need 3 sig figs. We're looking at this 9. There's a 6 next to it. So we need to round up. In this case, you can't go anywhere after 9. So you have to write 830. But that's not 3 sig figs. This on its own is only 2 sig figs. So what do? You add a decimal point at the end, and that would make it 3 sig figs. Or you can write it in scientific notation. A placeholder 0 is not going to help you here. So talk to me about this. Does this make sense? Sure. So explain why the placeholder 0 doesn't work here. So in 830, that 0 is a placeholder. If I added another 0 to that, so we've got 830 versus and then I'll add another 0. Those two are not equal. If your apartment complex said, okay, the rent is $830 a month, and you give them that, and they're like, okay, but there's still some missing, and then you see 8,300 written down, you'd be like, okay, wait, you added an extra zero. Adding an extra zero here changes the number. It's no longer 830, it's now 8,300. So, we have two options. The decimal point adds on significance. So when you have a decimal number, then all three of these digits, the 8, the 3, and the 0, are significant. In scientific notation, everything that you write in the coefficient is a significant digit. So whichever route makes the most sense to you, that's what you can use. Mastering chemistry may be a little bit more stricter. They may tell you, write it in scientific notation. For my problems, I'll leave it up to you, or I'll tell you. But it's, either they're both correct. So does that make sense about the placeholder 0 and how that changes our answer? Okay. Right. Then to 3 sig figs would just be 825. Okay? Alright. I'm going to erase that part because it won't make any sense for someone looking at it. But if you have more questions on sig figs, we can just do another session. So if you want to do one outside of the office hours time, just let me know. Send me a course message, or you can just let me know right after class. And that goes for anybody. So we're still talking about density. We're going to be in density for a little bit. Remember that volume by displacement thing? It's back. Oh, you're very welcome. So we did part of this problem. We talked about volume by displacement and how when we add a sample to water, that increases the level of the water. And the difference between the initial volume and the final volume tells us the volume of the solid. Here, we know the density of the sample. It's 3.33 grams per centimeter cubed. We place a sample into water and it causes a displacement of 8.0 milliliters. We have to find the mass of the sample. It's a lot of information, so let's organize. The question we have, what is the mass? That means that we're going to have something in grams. What we're given is the density. And we also know the volume. We're told that the green jade displaced 8 milliliters of water. That's our volume. We can rewrite that as 8.0 centimeters cubed because 1 milliliter is the same as 1 cubic centimeter, or 1 centimeter cubed. Given that information, I want you to solve the problem. Find the mass of the sample. I'll check back in 2 minutes. I'll start solving the rest of the problem. You can put your answer in the chat if you want to share. You can either put your calculator answer or you can put your answer with sig figs. Just make sure you have units. We know density is equal to mass divided by volume. In the last problem, we rearranged this to solve for mass. Since our mass is equal to volume times density, we're going to put in 8.0 centimeters cubed multiplied by the density, which is 3.33 grams per centimeter cubed. Your calculator answer should be 26.64. But how many sig figs can we have? Look at the information we have. Density, that's got 3 sig figs. But our volume only has 2. So we have to use 2 sig figs. The 6 would be the second sig fig there. So we've got to use the 6 next to it to round. The question was asking about a mass. So the units for mass should be grams. And that's why I do that in the very beginning. My question is about mass, so my answer should be something grams. And the math we did confirms that. The centimeters cubed cancels, and we're left with grams. So talk to me, how do we feel about this? Do you just need more practice? Do we need to go over this problem again? Or are you ready to move on and try another problem? Okay, we'll do some more practice. Is everybody kind of in that let's just do more practice? Because when I ask you questions and kind of guide you through the question, it seems like y'all are getting it. You just have to practice putting it together on your own. So let's do that. This is a very similar question. You've got a mass of metal that displaces a volume of water, and you have to calculate the density. I'll give you 2 minutes, and I'll check back in. I'm going to set up the problem. I always start by rephrasing the question. What we need to figure out is the density. So that means for our units, we're going to have some number and then grams per centimeter cubed, because we're talking about a metal sample, which is a solid. We also know that we can only have 2 sig figs here. The mass only has 2 sig figs. This volume has 3 sig figs, but we have to go with the lowest, and that's 2. We know that the mass is 5.2 grams, and the volume of water displaced by this sample was 12 milliliters. What that means is the volume of our solid is also 12. It's just that we customarily use centimeters cubed to talk about the volume of a solid. We also know how to calculate density. Mass divided by volume. When you substitute in your numbers, you have 5.2 grams divided by 12.0 centimeters cubed. Does anybody have an answer? And if you don't, you can quickly put it into your calculator and let me know what you got. Your calculator will say 0.43333 repeating, but with 2 sig figs, that's 0.43, and our units are grams per centimeter cubed. How are we feeling about density problems? I've given you a bunch of different types of density problems. I'm not going to give you anything outside of that. I can't throw you any more surprises. But how are these problems working out? Good. Exactly. That's why I always do that first. And I recommend that you write out what the question is. So what value are you looking for? And then what units that value is in. That will help you when you're setting up your problem to know, am I multiplying? Am I dividing? What am I doing? Because I know I need to have these units at the end. So all of that is purposeful. This is a good place to take a break. We've done all the density that we're going to do. We have temperature conversions and specific heat left to talk about. I talked about the difference between heat and temperature in the video. You still need to know that. We're just not going to cover it specifically in this live lecture. When we do exam review, I'll make sure that we go over one of those questions so that we have time to cover it in class too. So I have that it is about to be 3:34. So we will break until 3:44. A good 10-minute break. If you have questions, you can put them in the chat. I'm going to sneak away to get some water. But other than that, if you want to talk to me, I'll be here. Otherwise, 10 minutes, I'll see you back. All right, everybody. It is 3:44. Hope you enjoyed your short break. 10 minutes ain't long, but hopefully it's long enough for you to do what you got to do and shake your brain out. All right. We're starting with temperature conversions. I'll first give you a brief definition of what temperature is. Temperature just looks at the average kinetic energy of a particle in a system. So if you have a cup of water and you're heating it up for tea or something or coffee, whatever temperature that is, let's say in Fahrenheit, that relates to the average kinetic energy that one molecule of water has. The difference between that and heat is the whole system. So how much energy is in the system. Not going to cover that here, but it is covered in the lecture video that's already posted to YouTube. So again, make sure you know the difference, and we'll hit on that topic next week with exam review. Just because you're in college, I am sure that you've heard of degrees Fahrenheit and degrees Celsius. That's just two different temperature scales. However, you may not remember Kelvin from chemistry, or if you didn't take chemistry, you may never have heard of it. So the Kelvin scale is what's called an absolute scale. What that means is you'll notice there's no degree sign. It's just Kelvin. It's got a K. 0 Kelvin means no kinetic energy. It is absolute zero, the absence of energy. But with degrees Fahrenheit and degrees Celsius, you can have a temperature that's below 0. So those scales are relative. Kelvin is not. There are times when you'll have to convert from one temperature scale to another. That's what these equations are for. The top one, you take Celsius and convert it to Fahrenheit. The second one, you're taking Fahrenheit and converting to Celsius. This third one, we're going from degrees Celsius to Kelvin. Notice I don't have one for Fahrenheit to Kelvin. That's because you cannot directly go from Fahrenheit to Kelvin. You have to first take your degrees Fahrenheit and convert to Celsius. Then take that and convert to Kelvin. Is everyone clear on that? These are the equations. You will not need to memorize these. There will be an equation sheet. So for all your exams, there will be an equation sheet. What I want you to do is do these two practice problems. You're going from Kelvin to Fahrenheit for the first one, and Fahrenheit to Kelvin for the second one. Do these two problems, and we'll make sure that you can use all three of those equations. I'll give you 5 minutes to work on it, and then I'll check back in. So it's been about 5 minutes. If you'd like to put your answers for number 1 and number 2 in the chat, you can do that. I'll go over how to do it just in case some folks need some help. For question 1, we're going from Kelvin to Fahrenheit. But we can't just jump straight there. We've got to go from Kelvin to degrees Celsius first. To do that, we'll take 588 Kelvin and subtract 273. That gives us 315 degrees Celsius. To go from Celsius to Fahrenheit, you take your 315 degrees Celsius and you multiply by the conversion factor. And you should get 567 degrees Fahrenheit. That's our final answer for that one. For the second one, we have to go from Fahrenheit to Kelvin. Oops. Once again, we can't jump straight there. We're going to go from Fahrenheit to degrees Celsius first. And you get something like 51.7. Degrees Celsius. To go from Celsius to Kelvin, you're going to take that 51.7, add 273, and you get 324.7, which will round with 3 sig figs to 325. The reason we're rounding versus using the rules for addition is because we had to do multiple operations here. We did subtraction, multiplication, division, and addition. And in that case, you look at your problem and your given measurements. The only measurement we have is the temperature of 125 degrees Fahrenheit, which has 3 sig figs. Any questions here? We were doing so well, Blackboard. We almost made it the whole time. I'm going to share a whiteboard and then switch back. I can write that up there before I switch back. Equation. So